Hello everyone, my name is Mike Maldonado and I'm with the MCC Group in Fountain Valley, California. Welcome to the MCC Live Tech Days event. I'm here today and my goal is to introduce you to the L platform of machines, and there's three different varieties. So I'm going to walk you through the differences of the three types, and my goal is to enlighten you as to what can be done with these particular machines because they're quite versatile, powerful, and accurate. Okay? The first machine that we have is going to be an L32 Type 8, which is our entry-level machine. Now, the big difference between the L32 Type 8 and the L32 Type 10, which is what we have here, is that as opposed to having driven spindles, we have a back block with 5 positions that are static, so there's no live tooling in the back. We still have a gang slide similar to this, and with 6 positions and 5 driven positions. Over and above that, we have an additional unit on the back, which enables you to plug in what we call a driven dog leg, and that will allow you to put motorized tools and utilize them on a predetermined angular setting, okay, which is done manually. On this particular machine, on the sub spindle, we have a 3 horsepower continuous duty rating motor, and it's 5 horsepower 30-minute rating, 8,000 RPM. And on the sub spindle side of the machine, we have an X, Y, Z, and C axis that you can work with. Okay. On the primary side of the machine, we have our guide bushing side, which does have positive pressure, which enables you to utilize high pressure coolant without having to worry about any foreign materials or matters getting into the guide bushing itself. We also have 6 turning positions and 5 driven positions to do your cross working. Now, on the Series 12, everything is the same as this, but in addition, you will have a programmable B-axis on the very back side, and I'll show you where that comes in a second. I'm going to do a brief walk around on the machine. Let me first start by saying the casting is big, rigid, and thermally stable. We have hardening ground waves, and we have roller packs on those, so the end result is a machine that is extremely quick, accurate, and thermally stable. We're traversing the axis at a rapid rate of 32 meters a minute. Okay, so with that said, I'm going to go around and show you a little bit about the machine. All of the L family comes with a part conveyor. Okay. We also have here a chip bin, and the chip bin is where we extract the chips after the parts are manufactured, or we can take this out and put in a chip conveyor for unattended style manufacturing. Around this side here, we have a fine particulate capturing device, so as the coolant flows through the machine, the particulate matter, the fine particulate matter goes into this bin to keep it segregated from the coolant. We also have here a spindle cooler, which helps also in stabilizing the machine. Important. Like I said, it's big, it runs fast, and it stays stable. Back here we have the guide bushing, where we actually will detach the belt. We can take the guide bushing out of the housing and convert it to non-guide bushing mode. Okay, the difference between one and the other, if you're running in guide bushing mode, you can machine parts up to 320 millimeters in length. If you machine in guide bushing less mode, non-guide bushing mode, you can machine parts up to 80 millimeters in length. Okay, the single stroke of the headstock is roughly 12 inches, and the diametrical capacity is 1.25 inches, and there is a 38 millimeter conversion kit, which enables you to get up to about 1.49 inches diametrically. Okay, this is the pneumatic logic panel, which controls a lot of the functions of the machine. And then back here, we have rollers that are used in stabilizing the bar stock. And this is important because when you're trying to hold tents on a diameter this helps you a lot, especially if you're running in non-guide bushing mode. Okay, here we have a servo motor, which is on our cab bar loader. The cab bar loader, what makes it unique, it's an additional axis for the machine, and basically maintains the positioning accuracy and synchronizes with the headstock. So everything is always moving and conveying back and forth with their position. So we always know where the bar and the headstock are. Okay, I'm going to be now, this also, by the way, is the logics or the brains of the bar loader, where it controls the different functions of the bar loader. So I'm going to walk around now the bar loader and meet you back on the other side, and we'll continue the discussion. Okay, now I know that a lot of you folks have automatic bar loaders in your shop, but for those of you who don't, I'm just going to recap quickly what it basically does. This maintains the manufacturing cycle continuing until the bar stock runs out. The bar stock is put into these channels here, and the number of bars may vary because of the diametrical dimension of the bar. As the bar is signaling for a new, as the headstock signals for a new bar, basically the remnant is pulled back and it's deposited here in the remnant retract bin. Once the remnant retract bin, it's sure that it's released. The pusher tube comes all the way back to the home position. The channels open up. The new bar drops into the channel. The channels will then close down over the bar again. The pusher tube comes over the bar with a collet, and it pushes it into the work area, and we start the manufacturing process again. And it will continue to do that until such time as you run out of bar stock. Okay? So with that said, we'll go ahead and go towards the front again, and I'll get a little bit more in detail on the machine. Now, with these machines, there's one of our companies called CMA manufactures all of the attachments for us. And what that does for you, basically, is it enables you to be sure that any accessory that you put onto your machine will fit without any problem. The other very important thing, as far as Citizen goes, is that you have a single source responsibility for everything from the bar loader to the chip conveyor. So all you have to do is make one phone call, whether it's a bar loader, control, headstock, machine, programming, anything that you may have that you have a question on, we're there to support you. Okay, we have lifetime training, and again, it's a one-call deal. You just basically call in and we'll take care of the problem for you. Okay? Now, as far as accessories, we have a large array of accessories to help you change the configuration of the machines to better suit the part that you're going to manufacture. Okay, because the whole idea between these machines is to produce the part in the fastest cycle time. So what we do is we try and have a ratio of 50 to 50%, which is ideal. Obviously, we can't always get to that, but that's what our goal is. So back there are several different styles of what we call dog legs. There are driven dog legs. There are some with 3, there are some with 6, and there are some with 4. Also with different types of collets, ER11s and ER16s. Okay, that's used for the different types of tools. Those are mounted on the back side there and can be inclined manually at an angular position to facilitate angular drilling, centering, deburring, tapping, whatever you may like to do. It's also modular from the standpoint that you can convert it from a conventional 3-position stack on the dog leg to, on the pod back there that's motorized, to have up to 14 units, 7 on the front, 7 on the back, and they can be motorized, and they are completely modular. Okay, so with that said, you can actually change the configuration to suit the part. All of the attachments and accessories are manufactured by Citizen, for Citizen, warranted by Citizen, and you know, there's never an issue with regards to fit on the machines themselves. Now, with that said, let's go ahead and show the tooling accessory slide. Again, I'm back again with you, and I'm going to go over one more feature that we have, and it's called LFV. That stands for low frequency vibration machining. And essentially what it boils down to is that it gives you the ability to program your chips. And by that I mean by increasing or decreasing the RPMs or the feed rates, you can change the way your chips look. And as they break up, they'll fall away from the workpiece and will not wrap on your parts anymore. So whether you're running A286 or nylon, you will not have ship wrap anymore. It also gives you longer tool life, and it's available in 3 modes. We have one for drilling, OD turning, and for threading. And it is available now on the primary, which is the main side of the machine, and the subspindle side as well. Okay, now I'm going to show you a part that we did. This manufactured out of nylon. It's black nylon, it's extremely soft, and it's very conducive to wrapping chips around the tools because it's soft material. So what we're going to do now is show you a video of this part actually being machined both with the LFV and without the LFV. And again, it's something that is manufactured by Citizen exclusively for the Citizen product line. Again, I urge you, if you have questions on any of our products, accessories, call your local distributor, call the factory people. We're here to help you in any way that we can. Okay? So with that said, can we roll the video on the part, please?
As Mike told you, we're going to be demonstrating turning apart with using LFV on the L32 Type 10. Notice a large workspace area, easily accessible to get the tools. So we're going to face off. We're going to start with an ID move. Note how small the chips are coming through the drills instead of long stringy chips as you would expect. They're very small, very controlled. Also using axis superimposition so we can do 2 drills at the same time. Turning, same process, very controlled chips. As you know, with machining plastics, they can be very problematic, creating a real bird's nest. This isn't only limited usefulness for plastics, it can be used in all types of materials. See how the chips are just flying off there, very small, very controlled. This works really, really well, as you can see in a second with grooving. Grooves can be very problematic with chips wrapping up in the grooves. Difficult to get rid of them. Cutting down. The Type 10 and 12 now have LFV on the subspindle side. You can see here, controlling the chips as we do an OD turn. Not a problem with long stringy chips wrapping around the part. Very controlled as they fly right off. ID boring, same situation. Very controlled chips. Not getting long stringy chips. Not going to have a problem with chips being wrapped around the tool when the part's removed. Coming back around. Cutting off. Again, with LFV, you don't get the problem with the chips wrapping around the cutoff tool as you could with other materials or other operations. And it's done.
Good morning, I'm Bailey Stump. I'm an applications engineer for Marubeni Citizen here in Fountain Valley, California. And today I'm going to demonstrate some of the ease of use features of the Cincom control. And I'm going to start first with just basic tool setting. Basic tool setting first starts out in what we call the machining data page, where we have input our stock diameter. Then what we have is the preparation page. And this is where we do all of our tool setting. So right now, I'm going to install a gang tool at position 6. So, it's very easy to work with. I'm going to move the cutoff tool up. And one of the neat things about this is that I can actually move the material in and out. I don't have to go to the manual page if I want to get it back even with the guide bushing. Very intuitive. I'm going to call up tool 6. And you notice that there's a graphical display here, probably too small to see, but there's a graphical display here where it actually shows you what position you have highlighted here. I'm going to call that station to position. I'm going to jog the material out, again, not having to go to the manual page. And I'm going to perform an operation what's called man set. And I'm going to select the option diameter. The gang plate comes down. And at this point, I simply set the tool to the top of the material. Got to hand tighten the screws, and again, depending on what you're doing here, the machine knows which axis you want to move. Move it off the material. Tighten the clamp. That tool is now set. Top of bar is what we call it. So at this point, I'm going to call up the cutoff tool, which every program starts with. Jog the material out, and now I'm going to perform a cutoff operation. All done within the preparation mode. This operation can be performed at any gang tool position, so if you wanted to do a face cut to check center, there's other options for setting center as well. So at this point, I do what's called a start position. The headstock drops back to the machining data length, or the machining length, which is your total amount of material used to make the part. So let's just pretend that that was the last tool that we set and we're ready to check this setup, this program. Cincom offers an operation mode called program check. It's an awesome safety feature. It provides multiple ways of going through and verifying your program even before you actually even cut material. One thing that's also cool is just in the basic edit mode, the control will catch syntax errors and highlight them. So if you have like an extra decimal point or something like that. They even give you a description of what the issue is. Going back to program check, we have a mode that's called high-speed check. And what that does is it simulates the part program. It runs the part program, the machine does not actually move. It just runs through and checks for things like sync issues. If you have a queuing code that's off, or if you have interference in G41 or G42, it will catch it in high-speed mode. So, with that being said, so now it's running through the program. So it comes up with an alarm, compensation interference, and $2. So at this point, hit reset, go to edit, select $2. Well, it's not showing it. So anyway, I know what the issue is here, is that I have too big of a radius offset. Go back to program check. Let it run through again. We'll do this until it gets all the way through to the end of the program. Here, we see that we have a sync code that does not belong. Again, it makes it very easy to catch things before you're actually cutting material. It's a nice, safe feature, potentially save you a lot of money. Go back to edit mode. Go back to program check. It's going to run through again. It's run through the whole program. Simulation has completed. Now, the next step is actually cutting material. Cincom Control offers a handle feature in program check mode to where you can actually handle through the program. As you rotate the pulse handle, it advances through the program. You can adjust the speed at which it moves using your buttons here. What is a very awesome feature of this is that as I'm running through the program, I can reverse, I can go forward, I can let it off, no movement is happening. I have complete and total control of the advancing of the program. Again, if I see something I don't like, I can reverse it. Another great feature is correct. You can actually correct on the fly. Single blocking it, going it through, looks okay. I see something I don't like, so I go to correct. I go to the issue. I've just made an edit while the program's running. I go back to normal operation. Finish that block. And now I can continue with running the program. So it's very safe. It provides you an awesome way of making sure that your tools are going to get through the cuts okay. You're not going to damage the machine, and like I said, potentially save you a lot of money and a lot of heartache. So that being said, that pretty much concludes my demonstration of the basic tool set and the program check mode. So, okay, well, I want to thank you for joining us today, and please stick around for the B&J 51. Thank you very much.